So source basically is the controller where it can decide how it wants to reach the destination. So yesterday in SRMPLS, I generally wanted to go for some revision, but forget I don't have. I mean, I have already wasted too much time on one case there. So I will go straight forward to SRv6 today. So yesterday we did this source based routing based on
seat value.
I was saying that yesterday we did this based on MPLS level, correct?
Oh yeah.
Yeah. So today, remember I told that segment routing must bring as a replacement for MPLS. But it's not only that, they also wanted to bring it as a next gen technology. So next gen technology cannot be an IP technology. It has to be an IPv6 because your next gen network layer protocol is IPv6. The future is IPv6, not IPv4. In a sense, you can say that IPv4 is slowly and steadily becoming your legacy. So this SR was prominently designed based on IPv6. Now, what used to happen earlier is that what used to happen earlier that we used to forward based on the labels. As we said in SRMPLS also, we are still forwarding based on label. From SRv6 or in a sense, from as soon as you come into from SRv6 scenario, you are coming into a situation where the forwarding will happen based on the SR routing header. It's not label anymore. Okay. And this routing header or this SR basically segment or instruction is what makes this IPv6 or SRv6 much more complicated because you are not used to this. You guys are used to what? There is a packet will come, you will assign a label and then forward based on the label. Yesterday we see, right? What was the operation? Operations of label, general operations of label was what? You will push, you will swap, you will pop, right? In the end, if there is explicit null specifically mentioned, you will pop it as an explicit null. Correct. So same thing will happen here also. It's not going to be a label. You're not doing a label operation here. There is a different concept here. We called it insert. Okay. We called it decapsulate. But it's a very simple similar function. We will see below. So basically SRMPLS was what? Initiation or in a sense implementation of the segment routing technology on MPLS data plane. Basically what we are trying is we want to basically means in a sense install a segment routing technology over an MPLS data plane. Label swapping, label, in the end all you are doing in label, right? Yesterday we talked about only label and label. Except that source routing concept or the technology it brings, most of the things we talked about is label. But that is not the case. From SRv6, you are coming into the picture of a different thing. It's not going to be any more MPLS. It's a different header. Okay, but it's a header under an IPv6. Now, how do we identify that thing? We will come after this slide. So, what's the biggest advantage of SRv6? See, in the end, even for a SRMPLS, you required MPLS. So there is another component, right? SRMPLS, right? There is one component called SRMPLS and the MPLS is a separate component. You need label from whom? Who was providing label yesterday? LSD. MPLS LSD, right? Now no more such things. It's integrated within the header itself. The routing IPv6 header, right? It's integrated within that. So you don't need any other component. So you have removed the complete MPLS part. If anybody has worked for a long time in HTTPS SP, they should know we get lots of issues, right? In MPLS level programming, MPLS level not allocated. this kind of issues, right? So there is a lot of disadvantages of having a separate MPLS component, a label component. With SRv6, you are going to be free of this. Why? Because you are initiating, or in a sense using the information within the header itself. You are not adding any external header like MPLS here. Okay, it's all within the network layer protocol. So that's why they are saying no MPLS to the host, no RSB, TE, no TE, FRR, nothing. All those things not required. Why? It's simple. IPv6 header will take care of everything. Okay. Now we come to the SRv6. What is an SRv6? An SRv6 instruction can represent any topological or service-based instruction. What is an instruction? An instruction, for example, yesterday when we are doing the level operation, right? So basically when we say swap is an instruction, right? If we are saying some particular router swap level 16002, so that means this is an instruction. I'm asking this router to swap this level 16002 to some other level. It can be 16002 in SRMPLS. In MPLS, it can be a different thing, right? But it's basically we are asking remove this level, add another level. Swap. Okay. If we are saying push, it means push a label over whatever level there is, push another level over that level. And if you are doing pop means remove all the level. But in SRv6, the instruction is there, but it's decoded, or in a sense, encoded within the header itself. So a network program is a list of instruction. As I said, instruction is basically telling what to do. I want to say go to router 5. Okay, it's an L3 VPN service. Let's say example, there is one router R1 and R5. They are connected via a MPLS core. What will happen? BGP will send what label? VPN level, right? And transport will be MPLS. So MPLS will do what? Penultimate hopping, and then it will forward what? VPN level. So you'd see you are sending a VPN level extra. Why? To let that router know, the end router know that this is coming for an L3 VPN traffic. Based on that VPN level, the end router will understand that this is an L3 VPN traffic. I have to do some L3 VPN operations over it. Based on the configuration on the device, it will understand. So all these are instructions. So this is all you are doing via this VPN level. So for every kind of instruction, you put a control plane, particular label. For eVPN, there will be a label. For L2 VPN, there is a label, pseudo-wire label, right? So similarly, for SRv6, the similar instructions are there, but they won't be labeled. They will be based on a concept called SID. Okay, they will do it via SID, and this SID is what? Segment identifier. We used yesterday. We go into a concept called prefix SID, right? In SRv6, we are doing everything by label. Everything is done by label. So we are identifying the segment routing by that label as an identifier. Here you are doing it as an IPv6 address. So you will identify everything by an IPv6 address. So what is the thing? Whatever you learned yesterday, today you will going to learn a similar thing, but it will be all based on IPv6 header. There will be no more labels here. Now, because you are using it as a header itself, a label has limitation. It does not carry all the information. And header, a network layer header has a lot of information carrying capacity. So here itself, you can not only give the destination address where I want to reach. For example, if I want to reach R5, I will just add that global prefix level of the R5 from SRMPLS side. In SRv6, you can give the seed of R5, plus you can give the function, what kind of function you want to do there. All kind of these things we can do in SRv6. So this is just basic way of showing. Okay. Because of this label, right, you have to go through, one second. Because of this label, you have to go through multiple limitation in design, multiple inter-AS options, right? This label protocol is one of the reason there's this design scheme. Enter as option A, option B, option C. This inter-exchange communication between different ASs. For that, you have made multiple design. Why? Because to send the information of a label from one domain to another AS domain, it's not simple. You have to do some tweaking. MPLS was by default established or in a sense made for a single AS domain. See the basic structure of MPLS if you read. What they say, have a same code, /32 loop back. Okay. But now with IPv6, you don't have this limitation. You don't have to worry about all those designs and everything. So how do we do this? So these are the RFCs. So we do this based on two things. First is the SRv6 domain. As I said, right, there is called a domain. One AS, or in a sense, basically we call that particular customer autonomous system as a single domain. They have the same set of rules generally, and they apply that same set of rules. But let's say there is another domain. Let's say Kolkata is one domain, Delhi is another domain. Under the same customer, but because they are regional cities, they have different rules. Okay. So if you are basically communicating between two domains, how it will function? You can just put all the information for Delhi domain within the Kolkata ingress node, and it will automatically understand what it has to do. It's so simple. Means in a sense of operation, but in a sense of understanding, there are a lot of information you have to understand. You will not understand here right now. Okay, on this statement, if I go all through this, you will be able to understand. Once I go through all the other parts, you will be able to understand what I'm saying right now. For example, this is what I just wanted to say that this is a domain concept. Domain is nothing new. We know all this, right? A single MPLS core, it's an MPLS domain. You have an L3 VPN, you will have a single IGP core where the MPLS will run, right? So that similarly is an SRv6 domain. It's just there is an SRv6 running here. Okay. Now we come to the terminology. I have talked about the segment, right? Segment is basically what? Yesterday it was a label, today it's an IPv6 address. Seed is the segment identifier. How do you identify this segment? An SRv6 seed is an IPv6 address explicitly associated with the segment. For your segment routing, the IPv6 address we have taken is called SRv6 seed. Okay. So if somebody says, let's say some customer opens a case and he says, my SRv6, I am not able to reach this SRv6 seed. So you should understand he is what telling that there's, let's say, R1, R2, R3, R4, R5, 5 routers are there. I am not able to reach R5 segment identifier. Okay. Source node, transit node, endpoint node. It's a very similar to SRMPLS. In SRMPLS, you have an endpoint, you have a source, and you have a transit routers. We have seen this yesterday. Similarly here. So basically, transit router will not do too much. It will just work on the instruction given by the source node. Okay. Now we come to the part. What is an IPv6 SR header? So see, within the IPv6 header, there will be a specific field. This next header field actually what? This next header field tells you what is the next information I am carrying. Next header means what? Ethernet, after Ethernet, what is there? Ethernet frame, after frame, what? There will be something, right? IPv4. After IPv4, there will be transport protocol if there is any, or the payload. Just a normal packet. So for an SR or an IPv6 packet, within that header information, there will be another information called next header field. That next header field can be an IPv6 routing extension header. Okay. So generic, this is the RFC number. So next header can also include all the other. For a normal IPv6 packet, let's say it's carrying a TCP packet. So how you will know from the packet in the packet capture, you see the next header field. It will mention there. It's a TCP packet. It's a UDP packet. Similarly, it can identify an SRv6 header. It's basically an extension of the IPv6 header. It's not a separate protocol like an MPLS label. Okay. So these are all the RFCs. So within this header, after that, what it does, it puts the information. What it's saying is next header is my, let's say it's my IPv6, SRv6 header. After SRv6 header, your traffic will be there. So this is the just I'm explaining, as I said, right? Next header field 17. 17 is for UDP. It's not going to be mentioned UDP. These numbers you can get in internet. What next header numbers for an IPv6 ether type, you understand, right? Everybody, there's a ether value in Ethernet which makes you understand what protocol, network layer protocol it is carrying, or basically let's say a 2.5 protocol like MPLS. So say similarly for IPv6, whatever information it is carrying, he can identify by the next header field. So this is actually an SRv6 captured. Okay, you will not able to do it. I got it from internet, a PCAP file. Currently in Wireshark, we are not able to do a decode of an SRv6 packet because this is still, RFCs are still going on, not completely approved. This is a very new technology. Okay, so generally SRv6 header will look like this. If you see Internet Protocol 6, routing header 43, and then routing header for IPv6 segment routing. And within that, all the information will be there. Okay. But this is a very old structure. Right now, it's changed a lot. Why I'm showing this all? So that you can at least understand this is how the SRv6 packet will be. It will be changed a lot nowadays. Okay, there is a microsip concept came, but just understand this is how SRv6 will forward. There is no, see in MPLS what used to happen before IPv6 or IPv4, there will be an MPLS header which will say this is a label, and over that label operation will be done. Now no such thing. Operation will happen on the IPv6 header itself. Each segment is an IPv6 address, as I told earlier, right? SRv6 is nothing but an IPv6 address. And you can have multiple IPv6 address within a single segment header. If you go up again, see how many segments left there? 0. If you have multiple segments, you see that address field 0, 1, F1, F2. There you will have multiple addresses like that. Address 0, F2, address 1, F1, let's say address 2, A1, like that. I'm just giving an example. Okay, you know all right, hexadecimal starts from where? Where? Hexadecimal starts from where?
Start from where means
Which number it starts from?
after 0 to 10, after 9, 16.
After 9, what alphabets are there?
A.
So F is a
ABCD.
what? 15 in a sense, right? So in SRv6, what is happening is you are using the IPv6 address, which is an hexadecimal notation, right? So all this address you see in the field, this address, see my mouse pointer, everybody can see this mouse pointer?
Yeah.
Address 0, address 1, these are your instructions like label stack. This is your SRv6 stack. Okay. So this is what they are saying. Segments are encoded in reverse order. So what is the reverse order? So if my first packet is, let's say, put in last, it will be reverse order, right?
So it will be first.
So your lowest label will be showing first, but it will not be operated first. If you go there, again up. F2 is your destination address. See the source address and destination address there in the field. Destination address is F2. So F2 is your lowest header. Before that, there is F1. So we are clearly saying go to F1, remove F1, then forward to F2, the destination. Okay. Last segment is 0. First segment will be N. There can be, let's say, I'm just saying 100 path, 100 nodes between them. So your if 0 is there, 99 will be your first segment then. If there are 100 nodes, 0 will be your last one. 0 to 99, 100. That means active segment is segment left. So when you say segment left means how many total number of segment left. Let's say there is only one segment left, then it will be 0. 1 is 0, right? We are counting from 0. If you say 1, that means there are 2 segments left. I will show you in the packet capture itself. See, where it is, segment left 0. See, why? Because still it has to go to F2. Correct? This F2 level has to be removed. Once F2 is removed, there is only one segment left then. It's actually in F2. If you see source address 111:2 F2, it's in that router itself. It's going to operate on this label, remove it. It's the ingress capture. On router 2, where this IP address is 1121 hexadecimal IP address is to this I am saying. This address I am saying. This address ingress capture this is. So for this router, this packet will come. He will see himself F2 there. He will remove that address as a label. If it was a label, how it will be? Label 16,000 and then 16,001. But it will be again not in reverse. It will be in a proper order. Label of this, let's say 16,002 is this router's label. So 16,002 will be upper side before IPv6 and 16,001 will be near down end, correct? So it will remove the top level of 16,002. But then what will happen? It will forward to the next level. Basically, it will not be 16,001 because it's the last level, right? So it will do an implicit null or something. It will be the last hop where you are trying to reach. So this is what they are saying here. Understood? How the format is? Okay. So network programming is similar to segment routing over IPv6 data plane. We are not going to deal with our older architecture of IPv4. This is we will configure like this and it will happen. We will more think about dynamically here. If anything has to be done, we will do it in the source. Everything automatically will happen in the rest of the network. This is how we will set the and design the network. This is the main reason of bringing SRv6. Okay. So, if you see what they are saying, it allows for expressing any end-to-end service in a stateless manner as a set of 16-byte instruction. How much 16 bytes in bit is? 128 bit.
16 byte.
6 8s are what? 48, 4, 10. So basically what is happening here is 16 byte, right? 1 byte is what? 8 bits? So if you do 8 into 16, how much it is? 15 8s are 120. 16 8s are 128. So 128 is basically your IPv6 128 bit maximum size. That's why they are saying 16 bytes instruction. Don't get confused. Oh, what is this 16 byte? It's just an IPv6 address. These are just terminologies encoded in a packet header. So maximum length of the IPv6 address, you can put the information. So you're understanding the IPv6 address format. They're using it to put source routing information. Your IPv6 address is already there. You're creating another separate IPv6 address which will put all the information for your source routing. How it is done, we will see now. So this is done by this SRv6 SID format. What is the SID format? What is SID first? We talked about, right? Segment identifier. Segment routing version 6, segment identifier format. So how is this format? Locator node, function, argument. So let me just do some annotation here. So this locator block, locator node, this function, this argument, these are nothing but an IPv6 address. Okay, it's just the whole block of IPv6, right? We know it's a 128-bit address, right? It will be like this. How we write an IPv6 address? X dot X L, just saying, A and dot. Then again, right? 1, 2, correct? So like this, we are doing this. So similarly, all these addresses will be written, but there will be some information where locator block, locator node, function and argument will be mentioned within the same address. Okay. Where is the clear option? Okay, so let me just stop annotation. So what is the locator is encoded in the L-most bits of the seed. L means what? Leftmost. Most of the leftmost bits will be your, you can say basically, most of the space in the 128-bit size of an IPv6 address for an SRv6 seed will be taken by whom? Locator. What is a locator? Global prefix seed. Telling I am the one R1. I am R1. This is my seed. So for in that seed, his locator will be his identifier in a sense. Okay. Then locator node. Take it within a locator. Okay. Then comes the function. Now, what kind of information I am sending? I will not just send I am this locator. I will also send a function. What kind of function means? L3 VPN function, EVPN function, basic, let's say swapping function like an MPLS label. Here there is a different kind of function is there, push, insert kind of a function. What kind of function you need to do? What kind of argument is there? Okay. All these things will be mentioned here. Okay. This is the seed format. See, I said SRv6 seeds are 128-bit addresses. So what do you see from here? So you are understanding the color part here? That highlighted, the first thing which was highlighted, right? 6666, this number. I will go again. This part is your what? Function. Okay. This part is your locator. And this part is your argument. Why I'm showing you all this thing? Because this is how an SRv6 format is. Based on this SRv6 functionality will be done. What kind of different functions are? We will definitely see in the below slides. Okay. So segment format is local knowledge on the parent node. This format is decided by the local node. Okay. You can manually decide how my format will be, how much locator size will be, how much function size will be. Okay. But remember, we generally use the 48. /48 is the general used size. IPv6 subnet size, how you give? /32 like this, /32, /16, /48, /120 like this, right? You don't write 255.255, correct? You put it as a slash. So that's what I'm saying. So if you see, this is a /64 they have used. Just check it. It's a very simple diagram. If we see, if I take an annotation, this is your source. Okay. And the source is coming to R1 and it will go to R4. Sorry, my, source, actually, BGP, source is there, right. It is going to R4. Now, see this table field. Source 2001. So basically, you take this as a source address. And then destination address DA 2001 DB80111 : next hop this. So basically what you are trying to reach is from this source, you are trying to reach this BGP address, which is behind this router. Okay. Check the, yesterday we are checking on label, right? Label swapping, label stack. Here there is an IPv6 stack. See segment list. What is the first router in the segment list? It's a reverse order. Don't get confused. Don't think why 4 is mentioned here. We should start from here. This is the correct one. So what is the first router? 2001 DB801.11. Who is this? If I go in R1, what is the R1 locator given? 2001 DB8:0.:/64. You have given locator this much value. Okay. You have given locator this much value. How much it is? 16, 16, 32, 16, 48, 16, 64. Now you understand why it is /64. So this is permanent. This will not change. You have not given any chance. As a subnet mask, when you write and look back address 1.1.1.1/32, what does that mean? That address is absolute. All the bits are locked by me. Similarly, you have locked 64 bits here. So rest of the 64 bits, what they will do? Function, argument. We just talked about it, right? So here what was the value we got assigned? 1. 1 is for this R1. Think it as an identifier. Remember? If we go here, 1 second. Here, locator, function, identifier, correct? Block/node identifier. Now where this node identifier comes? Just go here, locator node. So there will be one thing before a function will be assigned, which is this value. This one. So from this you know, this is the router R1. So on R1 this packet will come, then what will happen? See the next frame. What will happen? It will go to what? 2. Then it will go to 3. Then it will go to 4. Okay. I'm just giving you an idea how the segment will forward. It's very simple to similar to SRMPLS so far. Any question, guys? Just ask it, because again in means I think once we go into the future part, it will be much more difficult then. Ask the question. Any doubt you want to ask it. Okay. I guess everybody has no doubt. Now comes the microSID. So far we see that there is a segment SID. We talked about it, right? It's a 120-bit, 80-bit address. And if you want to send a packet, let's similar, just check this one. If I want to send from this source to destination, I need 1, 2, 3, 4. 4 segment instruction, right? In the end, this is an usage of the header. Basically, you are increasing the operations, right? Even if you are doing it hardware, ASIC, the hardware has to look up all these things, right? If there are 3 label stack, you need to know what labels they are using. Correct. Similarly, here you have 3 address stack, 4 address stack. So 4 address needs to be looked, right, one by one. And you have to carry all this information in the header. That's an overhead, right? This is a simple operation. What about if you have a very complex network? How many instructions you are going to add like this? To overcome this, we have a concept called microSID. This U is micro, it's not a U. They also called it USID. This is a microSID. Okay. Some D, if you go to some Ds, they will call it as a USID. Okay. This is a microSID. That segment instruction you see, it was 128-bit given. MicroSID is nothing but it's a shorter of that. They have compressed it within a single one. What I mean by that, I am going to show you. Similarly, in IPv6, any network instruction, any segment SID, what we have seen so far, in the destination address or the segment routing header, we know where this information is kept in segment routing header, correct? Can contain a micro program of up to 6 micro instruction. How does it work? Let's see. A micro program contained in an SRv6 SID. Let's say BBB, it's just one locator name in a sense. Now all the instruction we can add it in rest of the, so first if you count it plus 16 and 16, how many bits there is? This is how much bits?
128.
128 bits. So how many bits in every octet?
8.
8 bits, right? So if you take 8, 16 bit, correct? If you just count 8, 8, 8, 8, 8, 8, 8, 8, 8. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 into 8 is 64. This is not. So will it be, it's really a 8 bit. One hexadecimal is 4 bit. So it will be 16 bits. So 16, 16. 16 into 8 is 128. So this is 32 bit. Okay. What it says within the SR domain, the operator is nothing but the engineer who is going to configure. Allocates a 32 prefix as this, where each B is the nibble of 4 bits. This 32 bits can be allocated from a public or private range. The instruction will be rest. So every instruction is a 16-bit instruction. Now let's see its actual usage. This theory will not help you to understand its actual usage. I'm going to show you how it is actually used, not here. You see this all. Now see this part. Source address, destination address. How many segment list we have here? 5. All these addresses we have to go do an operation and remove, right? So we go to the last hop. See the next USID. The same encapsulation USID. How does it look? Single address. But is it a single address? No. Check carefully. What is this 100, 200, 300, 400, 500? These are nothing but all this list converted into microSID. So rather than having a list of IPv6 destination SID one by one, we will concatenate or compress them within a single segment SID in the form of microSID. Now you are clear? So if I will show you. See this diagram, you remember? This is the same diagram. This is the same diagram, right? See here. What is happening? You have this 1, 2, 3, all these things, right? List. Then you go there, one list will reduce like that, correct? Here you come, what is happening? You have just a single statement containing all this information. See the coloring part. This orange, green, yellow. This is nothing but similar to this coloring. See, both have same coloring. Orange, green, blue, red. Here also orange, green, blue, red. Clear? So the toppest 0 will be on the rightest side. Lowest label will be on the rightest side. Toppest label will be on the left side. Okay, so when the address processing happen, if it goes to R1, see what happened? You see R1 anymore? Yeah? Do we see R1? Orange is there. Think like color. See, every color in every router will be taken out. Because it's processed. It came to me. I have to forward it to 3. It will go to 3. 3 will remove it. After 3, what will happen? It will go to R4, the final destination. This 4 is the locator of R4. This E is the function. So now think how it is. Earlier I said, right, in SR MPLS, we have a level stack. One level, 16001 for R1, 16002 for R2. So we are keeping a stack of label. One router goes, we remove that label and move forward. Think like that, okay? In SRv6, what we did, rather than the stack, we put an IP address. That IP address is called IPv6 segment SID. It's an IPv6 address called segment SID. That segment SID will be processed one by one hop, correct? And the segment list will reduce. But once you come to micro SID, there won't be a segment SID list like that. What you will do is you will compress it within a single segment SID with the help of what? Micro SID. Okay. Now you understood why micro SID was built. Now we go back to the theory again, because what happened, you without this understanding, you won't be able to understand the theory of micro SID. Compressed SID or micro SID. What is this? A short encoding of a segment identifier in an SRv6 packet. That does not include the segment ID locator, block bits, and these two information we have removed. Segment ID locator and block bits. Okay. A micro SID is a type of compressed SID referred as next compressed SID. Micro SID locator block, a block of micro SIDs. Micro SID container, a 128-bit SRv6 SID that contains a sequence of micro SID. It can be encoded in the destination address of the IPv6 header. What does this mean? See, just remember this: active SID, next USID, last USID. Okay. Now we come to this part. We will understand here. See, that 2001-08 DB8, this is my USID block. I have to decide, whenever we configured SRv6, we have to decide a block. Remember global block, label block yesterday, 16,000 to 24,000 for SR-MPLS. Similarly, for SRv6, you have to decide a block. It will be a block of IPv6 address. That IPv6 address you cannot use anywhere. It will be only used for SRv6. After that block, what is doing is every single 16-bit IPv6 address block, it is using for a microbit to understand how to do this. And this last bit will be your end of container. Basically, it's the last function. See, if your packet reaches the PE end node, what to do with that packet? For example, if in a label stack, if it reaches a L3 VPN node, there will be a BGP VPN level, right? Similarly, there will be a container function here which will give him a hint. This is a VPN v4 label, like that. Okay. And based on that, they will do the work. Okay. See, let's see this example. For example, a micro program of 3 micro instruction has the following structure. The active micro SID, that's the currently been executed. What is the active micro SID? USID1. USID1 is your active micro SID. Then once USID is completed, this micro SID, this basically let it comes to my router 1. Active micro SID 1 is router 1. It comes to router 1. Router 1 checks that packet. He find out within the IPv6 packet there is a micro SID 1, which is his own micro SID. He removes that micro SID. Then he finds out micro SID 2. He forwards it to micro SID 2. That is router 2. Then router 2 go there and he does the same thing. See here what it's saying. The updated micro program is the result of the operation. The completed micro SID is popped. It's getting removed. They will remove this micro SID. Okay. This is not a swap. You are removing this micro SID value. Okay. So the address will become shorter. And then they will move to the next micro SID. That is what here happened. If you see here again, 1, then it goes to 2, then it goes to 3, and then it goes to 4. Okay. Clear? But remember, I'm telling you again and again, remember in actual lab, when we will see this, you won't see like this. It will have a direct R4 information. Like segment routing level yesterday, global level. R4 has, if any destination has a global identifier, we just forward it based on its global identifier. Do you include R2, R3 level value? No, right? But the real operation happens like this, right? It goes to R2, then R2 finds this is the R4 and I will forward it. Similarly here, it also happens like this, but for your explanation, this is all shown here. Okay. What happened? Okay. So segment, as I said, the locator is what? Is the locator block for the SI segment routing identifier and the parent node initiating this particular, whichever node you are configured, from there, the locator will find out that node identifier. Okay, you are configuring that. Second is your function. What is the function? It requires, it's an opaque identification of that particular seed. What is that seed is going to do? It's an, let's say it's an MPLS operation. I'm just giving an example. It's an L3 VPN operation. It's an eVPN update. What kind of information it's going to carry? All this will be based on the function. And what is an argument? Argument is generally used, let's say, the end point, the last hop, right? Now, for example, you can say have a function for even for a transit node. Let's say an SRT, right? An SRT, you might have a function for even for a transit node that you might need to switch a path if you see any kind of break. But for a argument, it will only be for the end node. Okay. Now, how this thing is done is basically I'm going to show you. See, similar global UCID, local UCID. There we have global label and prefixed label, global and adjacent labels, correct? Here we have a global UCID block and a local UCID block. Local UCID you don't need to manage, similar to SR-MPLS, but like their global SR-MPLS label range you have to define. Here you also have to define the microSID or UCID range globally. Okay, that's the length part. Now let's come see this thing. This is the function E00. What is the E00 function? It's a cross connect function. We know cross connect, X connect. Everybody knows X connect, right? So it's simply telling R1 E00 is your cross connect function. UCID locator block FCBB BB00. So what it becomes for a cross connect? For R1, it becomes like this. The locator node is 001. See, let me just take the annotation. See, this is, I have configured the UCID block. Like this configuration I have put in the router. So for this, it will add a locator node 001. And this will then add a function called XConnect. There is no argument here. Why? We have not mentioned anything. Okay. This is just a basically packet formatting, just showing that list in the last order, all those things, not for microSID. Okay. How it will forward, see, destination address, then the capital though. This is old. What I'm saying is, this is the basic SR SID. Nowadays, SR SID is not used, microSID will be used. Okay, its RFC is already been published. Cisco is going with microSID. Okay, it's published by Cisco himself. So now we come to the functioning. Shift and forward. This is like the concept of swapping, push, all those things. So shift and forward is what? See here, R1 sends the packets to R2. R1 gets a packet, check here. We just talked about this. R1 gets a packet with a microSID 100, its own locator identifier. What it does, it's remove this microSID 100, it shifts this function 100 and forward rest of this. That's why it's called shift and forward. Shift and forward, okay? Means shift one particular microSID and then forward. This is similar to that endpoint X. This is what? The function part. X connect into an L3 adjacency. So let's say this is a microSID that represents L3 adjacency from node N to J. Shift and forward to X connect. I want to forward a packet to a pseudo wire. I have a pseudo wire IPv6 SRv6 setup. I have configured a pseudo wire from one PE to another PE. How I will forward? See, once R2 comes, it has to forward to what? Some router, right? So it forwarded what? It shifted its IP 200 out and then it forwarded to, see very carefully, there is no R4 information here. Why? Y. What is this? X connect. Let's say a router is there, R2, which is connected to a router called R5. They have a pseudo wire X connect. For them, is there any router in between? MPLS, think like an MPLS. Two routers, R1, R2. In between there is an MPLS core. For an R1 and R2, for their pseudo wire, is there any router in between? Yes or no? Nothing, right? It will forward R1 to R5. Similarly, in SRv6, R2 knows that once I come here, I have to give a function to whom? F2, A4, R4. See, this is the F2, A4. This is what is suggesting the R4 here. But what it is saying, my main functionality is this 500 one. This 500 is the locator of R5, the pseudo wire node. Okay, and then it will go to the functionality of F5D1. N2J shift and forward. So what it did is, when it came to R2, it's removed this information, it forwarded directly to the end pseudo wire node. The R3 and R4 are just what? They're transit MPLS kind of. Here it's a transit SRv6 node. Okay, they're pointing this information simply telling in R2 X connect traffic comes, you forward it to R5 your pseudo wire endpoint. Okay. See, this traffic, when it comes to the pseudo wire endpoint, what it will do? It will decapsulate the traffic. What's a pseudo wire does? It first encapsulates the traffic, right? Traffic comes, it puts a pseudo wire label, it encapsulates it, send it via the MPLS core. Then it goes to the destination pseudo wire router. There it takes that label, decapsulates it, and forward the L2 traffic via the attachment circuit. It is also doing the same thing. How it knows it's a pseudo wire traffic? By F5DA. Here, F2A4 is telling R2 that this is a pseudo wire traffic. This F2A4 is telling R2, this is your pseudo wire traffic. You encapsulate this and send it to R5. Don't worry about the MPLS core. We will forward it. When R5 gets the traffic, it knows that 500 is myself, and this function is an XConnect function. So I will decapsulate and forward it to this client. Okay. Local decaps and table lookup. See, every local usage that represents a decapsulation. How do you understand decapsulation? It understands by the function. Okay. It's understand by the function what to do about this. It's like an end DT. Function and argument, sorry. It will use the function. Function will tell him it's an XConnect. Argument will tell him decapsulate the traffic. Decapsulate means what? Remove this XConnect header, no need anymore. Send this packet to this C attachment circuit. So these are all your functions. So if I just show you here, end UN, end X, what they mean, there is a table, keep a print out of it. I'll show you here just 1 second. These are all your functions defined in SRv6 network programming. So let's say I'm just giving a very simple, the one we know very well, L3 VPN. If there is an L3 VPN, you will send this kind of a function. For a V4 L3 VPN, you will send and DX4. Okay. For a V6, end.dx6. So what this says is, this is the end router, PE router, end PE. I'm sending from source. So this is the destination PE. And DX6 says this, decapsulate here. So what you are doing with the BGP VPN level, right? You are sending a MPLS transport under a BGP VPN level. BGP VPN level over under a MPLS transport. So MPLS will send it to the destination PE. PE will get that VPN and he will know what to do, right? Similarly here, when the end node PE gets the packet, it will find out by this function ndt.dx that this is an traffic for my L3 VPN IPv4 table. Okay. That's what it's saying. For example, for cross connect, we said right cross connect how it will understand. See, there is a eVPN, unicast, then L2 VPN, and DH2. See this one. NDH2. From NDH2, it will understand that this is my layer 2 cross connect L2 VPN. Okay. So let's stop this annotation here. Let's check this in lab. We have seen so far in theory, correct? So everybody can see this router? Yeah. So how this topology is, I will show you. We'll come to this part, okay. This is your SRv6 core. Okay. And these are your client. They are sending a L3 VPN traffic, same L3 VPN. Let's say these are two customers. Okay. This is your Kolkata, this is your Delhi customer. This is your all India core. You connect this customer here. What you do? Think like an MPLS. You will add a BGP VPN v4 family. You will put it in VRF. You will then what? You will encapsulate in a VPN v4. Then you will send it over the MPLS code to the destination. Similarly, you will do everything same. Just you will do it in a SRv6. Okay. There will be no MPLS encapsulation. So let's check how we will do this in a lab setup. So this is my router R1. We have seen the diagram. Everybody understand how the topology is. You need to take a snapshot. You need to take a snapshot for easy to understanding. You can take a snapshot. I will show it again. Take a snapshot of the diagram so you can understand easily. You keep the diagram open. Okay. Everybody done? Or I have to, one second.
Oh, 1 second, Naresh.
Yeah. Take the snapshot so you can understand when I'm saying R1, R2, R3. Okay, what is happening?
Is previous diagram? Please go to previous diagram.
Previous diagram is not required. Just take this one. Okay.
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 This meeting is being recorded.
It's already recorded, right?
I'm doing something. Just give me 1 second.
Okay, mute it. Or you can keep this diagram.
Naresh, please previous diagram once more.
Okay. This is just to give the IPv6 loopback address of your core. This is your actual flow. See, the customer is eBGP, and then you have an IBGP of your own domain. Okay. So guys, ready?
Yep.
Okay. So R1 is a PE router. In the diagram, we can clearly see, right? And who is the other PE router? R3. Everybody see your diagram. R1 is the one PE router, R3 is your another PE router. R2, R4, R5 is your core routers. Correct? You have two paths, one going via R1, R2, R3, another is going via R1, R2, R1, R4, R5, R3, right? R6 and R7 are your customer CE router. So, if we go into this router, if I type a show route, what I see? What is this? Are you little shocked? Why there is only this much routes? It's a core routing going on, right? Anybody?
Global routing table,
No, I mean, even if it's a global, it is a core router. It's connected to your core, right? It's a PE edge router. It should have routes for the core, right? Why it is not showing in the routing table? Madhul, Ashutosh, these guys are new, I understand. 2 months they have just joined their team. What about you guys? Why are Ashutosh?
Because we have not configured anything, na?
Okay.
Because only because the SRv6. The requirement is
Manami,
different.
Vishal, Dhanush, Shanim. And how many people are there right now in the training?
3, 4,
6, I think.
In the WebEx, I'm saying.
4.
So Manami, Vishal, Dhanush, and Shanim. Okay. Guys, why we are not seeing anything in the routing table? Check the first diagram. I have given a hint. Why we are not seeing anything? Just 1 second. Sorry. Hello. Yeah. What is SRv6? Which format it uses? Which format of network protocol it uses? IPv4 or IPv6? So when you type show route, which routing table you are seeing by default? So how you see an IPv6 routing table?
Yes.
So you go into a customer troubleshooting, you type show route, you ask him that I don't see any routes in here, there is a problem. He will either laugh or he will escalate, see, I don't want this engineer. He doesn't even know that how to check a routing table. That's why I asked this question. So if you type show route IPv6, what you are seeing now? All the tables are there, right? So first of all, be sure what you are checking. Okay, don't get confused. Actually, SRv6 is not that difficult. It's difficult because we don't deal with IPv6 in our day-to-day usage. But with SRv6, you can understood everything will run on IPv6. Our SP will completely run on IPv6. End customer will be still using IPv4. So you will be rarely touching IPv4 then. So get used to IPv6 more and more. Now, what was the first thing? Remember, we have to configure global block, right? Like SRMPLS. So did we configure it? How do we check a global block? Show run segment routing. See. What is this source address 2001? If I type interface, loop back 1. Show run interface 0. You got the address where it is getting it? Everybody got the address? When I said, what is this thing I have taken? SRv6, segment routing, SRv6, encapsulation, source address. When I say source address, this source address, you remember in MPLS, you go into MPLS, then say router ID. You mention the router ID of loopback, right? Similarly, this is like your router ID. Okay? Then locators. Locator. This is the name of a locator. Within the config, it's just a name. You can keep it anything. Then you put a micro segment. As you are going to use microSID. What is a microSID? USID. We just talked about USID, right? If you are not using this, then you are not going to use USID. You will use normal segment identifier, which are 128-bit long for every segment. With microSID, you are going to compress. So you are going to use what? Microseg UD. This is the behavior. This is a UNode, and we call this point-to-point USD. This is how the microSID format will be. By default, we are using this format. Okay, so you don't need to worry about this. Now we mention how the microSID will be. So we said it a 48-bit, right? We said it 48-bit. So what will be 48-bit? 16, 16, 16. How much? 48. That's why we have said it 48. So this is your locator. Mainly you are using to identify this node from this configuration. Okay, this is your block. Clear, guys? Everyone clear? Now, how do we see this configuration is working or not? Show segment routing, SRv6, locator. Sorry. You got it now? We see this locator is there. Now, if we type a locator, we see both the locators here. Why? Guys, what happened? Is there something pinging or someone?
Sandeep.
Okay. So what is this we are doing here? SRv6 locator main. Any locator you put the name or something, you will get this output. Okay. So SID all. Now you see all the locators you will get here. Check very carefully. This is what it is saying. 48-bit. This is one you configured.
SID means locator. Locator means network ID, no?
Yeah. So this locator you have configured there. Now let's go to the slide. Let's configure. Let's check the behavior here. Okay. What was that mentioned there? What was there mentioned? Sorry. What was that? UN. What is the UN function? What is an UN function? It's mentioned here. No. Why? I'll show you why. UA connect into L3 adjacency. UN shortest path to node. This is your default function. See there in the table itself. You go to the table. You go to this table. It's clearly said this is the default function. Okay. It's mentioned there. It is owned by whom? SID manager. Okay. This is your default segment ID. Micro segment ID default is your this one. Okay. Which you have configured. Now it will assign one by one ID for usage. For example, let's say this gigabit 00 link under an ISIS. What it is does? It assigned same locator with a what? Function. What is this function? UA. What is a UA? Basically, it's saying go towards the next adjacent router. Okay. X connect into L3 adjacency. This UA saying X connect into L3 adjacency. This is an X connect function. There, what it is saying? Local UA. Basically, it means any traffic comes to this particular header. If it has this header, sorry, this one, what I have to do is I have to forward it here. Gig 000. Okay. So if we check in the SAP table, show SAP IPv6, this one. You see the information, what it says, what is this value used for? I am in R1. I just type this value. What it says? SRv6 UA endpoint PSP UHD, that's the microset configuration. You remember, show, run, segment routing, PPSP USD. Okay, so don't get confused about this part. This is an SRv6 endpoint. Okay, XConnect to L3 adjacency function. Okay, it's a basic function. What it will do? Remote adjacency to gig 000. Where is gig 00? If I type show run interface gig 100,000. If you see in the diagram where it is going, anybody? R2. Now you clear? So if we see what it is saying, if I have this as an header coming to me, I will forward it to R2. Okay? See this part now. What is this? SRv6H insert read SID list. This. Who is this FCB BB013:2::? For whom we are doing all this? Who is this person? We are learning it from R3. Now you understand what it is, why it is sending to R2, why there are two paths. We have two paths to R3, and that function is for actually forwarding to R3. For in R1, we have locally defined this function, okay, to forward it to whom? R3. Okay, clear? So let's go back to the slide. IGP for microSID. How are you going to transport this information throughout your domain? What are the mechanisms available? Like SRMPLS, you can do it via IGP or you can do it via BGP. Okay? You will see most of the time it will be done via IGP. Okay? What is end function? What is endx function? What is the capabilities? What are the max SID depth values? Okay? For different function. So if we come down and see an IPv6 example. So basically, whenever you configured an SRv6 and you see a database, you will get all the information. For example, for a locator, this is an R2 locator. This is the end SID. This is the value. This is the block structure. So if I go here, show ISIS database R2 verbose. So for R2, this is the IP source address of R2. One was ours, correct? Now you see this. These are the these are the routes we are getting from there. Okay, but now we come to the prefixed part. See the functionings here. End x6. So this interface, this is the end SID. You see, this is the SID we are getting from R2. What kind of SID this is? Endx SID. What is an endx? If we go back to the slide, what is an endx? Endpoint function with layer 3 XConnect, the XRv6 initiation of adjacency SID. We yesterday learned about adjacency SID. What is the use of adjacency SID? To point to my adjacent router. In SRv6, how do you point to an adjacent router? End.x. You see end.x mentioned in SID, that means it's pointing towards your adjacent router. Okay? See, again, endx SID. This is your SID value. This is your UA. forward this, and this is the algo. What kind of algo you are using? This is a flex algo. That's why you are using saying 128. We are using flex algo here. If you are not using flex algo, it will be algorithm 0 default. Okay, just I'm giving a hint why this algo is 128 somewhere and somewhere algo 0. Algo 0 means default, 128 is the flex algo 128. Are we getting any other function here? Anybody? For example, not let's see here. Yeah. You see this function UDT4. Who is the owner here? Like a label owned by BGP. This seed is owned by BGP. So if I go here again in the slide, NDT4. Remember I told NDT4. NDT4. See here. I will highlight this. This one. Okay, so I will now remove the annotation. NDT4. It's an encapsulation used for L3VPN. So in R1, we have a BGP saying that this is an HPE router. Okay. Let's see a packet flow. So you will have a clear understanding how this works. Okay. I'm not sure if I have kept it here. Okay, no problem. I will just show you right now. Then we will go with this flow, and I think we can then end the session. So I will show you one packet flow here. So let's I told you, right, R7 is our what? Customer, correct? So if we go to what happened here? So let me just increase the font size so everybody can watch it. XR VR. Okay. If you type show route, you will only find R6 route here. See, 66666, correct? Now what I will do is I will go. R7 is connected to which router? R1 or R3? R1 or R3? R3, right? Now what I will do is debug DPA DPM. Sorry. Debug controller. I'm just enabling a packet capture here because this is on XRV, so we have to do it like this. Packet trace line. Basically, I'm going to capture 100 packets. Okay. On FT logging buffer debugging. Exit. Yes. So I will go in R7 ping 6.6.6.6 source 7.7.7.7. Done. Now let's see the capture. Show controller DPA packet trace. Enter. What was that ping packet, right? It was a ping packet, if I remember. So let's see the ICMP packet here. I think it will be best to filter it out. Okay. Fade. Though this is a flow level. It was 7.7.7, right? I remember. So I can just. Okay. Where is 7.7.7? Did anybody see here 7.7.7? Okay, let's do one thing. Let's run a whole lot of pings so we can get a packet. Count. This is so from we are pinging from R7, right? R7 is connected to R3. So from R3 it will go to R1, right? Or vice versa. So if you see this is not the one actually. This is 2001 to 2003. Okay, let's do one thing. Let's go to R1. So in R1, if I just want to see, okay, show route VRF 1, we have a R6, R7, correct? So if I type show route 777, see this. What it says, routing entry for 777, 2003 from 2003. From R3, I am learning this R7 IP. IPv4 address, I am learning this from R7. Very clear? So if I initiate any ping from here like this, so I should generally have a packet coming from R3 to R1. So when we am sending an R3 to R1 packet, right? IPv6 address 6667 2001, not this one. ICMP v6 solid session, okay. Says IPv6 TCP packet, okay. Begin ICMP or in ICMP, let me just check. Neighbor solicitation. Okay. Let's run it again. I hope I can show it here. Actually, that's all. So no, it's not coming here. So there can be chance that this packet is not traveling by this. Okay, so let's see here. So it's saying I'm going via this and this. So if I type show route IPv6, this is in default table. You can see it here. Okay, paste. What it says, from this protected, from this. So how I'm going via this is this protected link. So if I go here and type show sef for particular this router, detail. Actually, I have to mention IPv6. What it is saying? I will directly what? Next hop is this, and I will forward it to this particular destination. If you see in R1, when I say 2003, it says I'm going to directly forward it to this destination. So if I just type detail, do we see any segment routing information here? Any SR information? No, right? It's directly forwarding. Where is the SR function? All those things we have mentioned. We have seen this, right? Now in the lab, when I'm forwarding a packet, when I'm pinging something, where is the SR function? How does what it says in the route? When I say VRF 1.7.7, it says I'm learning it from this. When I go here, I see this. But when you see the BGP information, you will understand where the SR information is. Show BGP all. Let's do this. What was that? 7.7.7. Sorry. Show BGP VRF. My bad. VRF 1 7.7.7. Now you see the sub TLB.
Yes.
Cell structure.
Yeah, so this SID structure, this information is in your control plane. When data plane happens, it's a plain IPv4 forwarding always. That's why I told you, right? All these things I'm showing in theory, you will not going to use it. Practically, data plane forwarding will happen on IPv6. That's it. But how does it works internally? That's something you have to understand. Okay. If I type show Ceph VRF1, what was that? 7.7.7 detail. You see this encapsulation? What is this encapsulation? FCBB013E002. What is this? We want to see this. Let's go to R3. Show segment routing, SID, all. Sorry, SRv6, SID, all. What was that? FCBB013E002. What is this? Where it is going? Where it is going? Where it is going? And this, check carefully. This is a SID list for this link. FCBB013, sorry, 3013E002. This is a SID list for this link. Okay. And your next hop is this link. FCB103::128 via this 148. Who should have this configuration? Who should have this configuration? R3. Like R1 has a BB011 default. So now see how the global identifier is used to program it. And then they are saying this encaps read. Say why this is added. You want to understand. This is added as a backup. See FCB1E002. If I just type here. FCBB13002. Okay. this one. If I just go for this information, how this is learned, shows it will be under, yeah, shows Ceph VRF1 IP, sorry, shows Ceph IPv6, this. Who is advertising me to this? If I go in R2, shows Ceph VRF, sorry, not VRF, IPv6, paste it. Who is advertising me to this? It says this, where is the protected one, TILFA protected 001. So where it going to 001? Show run interface, kick 001. R3. R3 is giving the information via BGP that this is your seed to reach me. And I'm going to use this seed to reach R3. Not how will the packet or the, basically, if it was a viral or a CML, I could have shown you on the viral capture, right, on the link capture directly, that this information will be there in the header to forward the packet. What happens is, with this information, see, we see in the fib table, if R2 gets a packet with a destination address of this, what it will do? It will forward, right? Here it is clearly programmed. I am going to forward it to whom? Gig 001, which is R3. If I go to R3 router, what it will do? If I just take the R3 router, apply, show segment routing, SR v6 seed all. Remember that seed, I'm pasting it here, sorry. F601, what was that? FC01, where it is? BBE E002. Remember the last part only, E002 for convenience. Where is E002? UDT4 BGP1. VPN v4 function, in the definition we have learned it, right? That this is for L3 VPN v4. I can again show the slide required. See, end DTT4, endpoint decapsulation. Decapsulation means what? Remove the complete SRv6 header. This is what mean by decapsulation, pop. Complete popping of the SRv6 header. But we are not going to use the word pop here. What we are going to use? Decapsulate. Remove the header itself. Okay. So, if we go here again in the lab, okay. So, if I get a packet in the Ceph table, the line card will work with the Ceph, correct? You are not going to run an RP every time you get a packet for this destination. You will program it in the line card. See, if I check the line card, what it is programmed here, what it says, endpoint UDT internal do this. So if I type detail, recursive lookup in a table says next hop is this. What is this next hop? Show Ceph VRF1 IPv6. Drop adjacency. Why? Because what we are saying here is endpoint UDT. Once this packet comes, what is the endpoint UDT will do? What they have said in the definition? Endpoint this DT4 with decapsulation and IPv4 table lookup. So 7, let's say R7 is R6 is coming for R7 from R1. It reaches this router. SRv6 removes this SID value, the one which we are seeing right now, E002. Once it removes it, it will do what? It will do a lookup for R7 IP address, the destination IP address of R7. And if I type show route VRF show route VRF1, simply like this. We have the R7 via 103377. We got the lookup. We will forward it based on IPv4 lookup, the normal IPv4. So how was the whole flow? If I go to R1, if R1 has a show route VRF1, which router is connected to R1? R6. So 666 sends a packet to R7, which is a other domain router, not other CE router, connected to my other PE BGP L3 VPN node. What I will do is I will encapsulate it. If you see the step table, here I will encapsulate it. What? I will encapsulate it with what value? Here SRv6 head and H means head. Encapsulation red means I'm going to insert this particular SID value and send it forward. What will R2 do once it gets this SID value? And how does R1 decides that this SID value has to go to R2? We see the fifth table again. So if I take this value, show route IPv6, we are sending it to R2. This is going to R2. Okay. We are learning this from R3. R2, what it will do? It gets it, it's forwarded to whom? R3. Okay. And then R3, what it will do? NDT4. We have seen this, right? Yeah. What is mentioned here? SRv6 endpoint UDT4. U is microSID. It's similarly NDT4 because we are using microSID. It's going to be micro DT4. What is DT4? Decapsulate the whole packet, remove SRv6 header, do an IPv4 lookup. For that IP we are pinging 7.7.7. It is known to us. We have this in the routing table. We will forward it like this. Now you understand how an SRv6 flow works. So if we all these things, right? All these things now. Here, this is an example. Okay. The basic type of micro instruction or the SRv6 basically instruction is that function. Basic function is called UN. Remember the most basic function we checked, UN, default UN. What does it does? It specifies going by the shortest path to node following by the activation of next microSID program. If UN says this SID, you follow that SID where it is pointing towards. Okay. Here it's an example. Let's say this BBB colon BBB 800 is an SRv6 locator you have configured, global SRv6 block you have configured. Then the IPv6 route is this. Any IPv6 router will route a packet whose destination starts from this along the shortest path to node T. What it means is, if let's say node 8 has this particular microSID and you have a what you called IPv6 route like this, it's clearly telling for this subnet you pass the route directly to this router. That's it. For every other router, with that particular BGP seed, we understood, right? We have to send it to R3. That's it, nothing else. See, for example, here 278. Now let's assume you want to transport, this is a SRv6 network. You want to transport something from site connected to this node to the shortest path through 8, then 7, then 2. Basically what it is saying that you want to send something to this node 2, okay, via 8 and 7. Something is coming from 1 to 8, 7 and 2. Means from 1 you are sending the packet to 2, it will go via like this, 8, 7, 2, okay. Means what I am saying is, you send some packet from 1, it will go like this, okay. That's what they are suggesting us. Now what it says, packet goes to node 8, node 8 realize that this is my packet, I will do what? I will forward it to 7. I have a programming for that. We see that, right? When the BGP seed value 7 find out, I have to forward it to this node. He will forward it automatically, okay. Similarly, this will done. The useIt functioning is basically what? It's going to concat all the information within a single header, okay. Now if we go to this diagram again, sorry, lab again, and we go to this R1 router, when we check that value, right, the first value, this FCCB B1 E302, did you see any microseed here except for router 3? Why? This all happens in the background. That's the theory for your understanding. It works like that. But for you, in the TLI, in your eyes, you will see only like this. Like SRMPLS, you only see 16003. All the routers are saying coming 16003. Take the what we call swap 16003 and again add 16003, right? It's the same functionality here. But how it actually works, that's how it works. It creates a seed, then it pops one by label, okay? For your understanding, this thing is mentioned here. That's why I said that you might not require this, but you have to understand how microseed works, how the operation is. Okay, why this size is like this? Why we are not creating a list? Let's say customer asks you, I am not seeing the segment list. Where is my segment list? You have to explain him them. Let's see, SRv6 works like this. What you are seeing is that direct information of the destination node. That's all you need. All the encapsulation and decapsulation will happen based on that NDT or the other function list we have, right? That statement of lists. So all the functions we have, that will decide what it has to do on the destination node. So first, how you will troubleshoot, you will first find out what SRv6 function you are getting to transport that packet. We find out via, right? Show BGP detail, show SPF detail, we might, or show ISIS detail, we will find out the function. And then what you will do? You will do the troubleshooting based on it. For example, we know that BGP one. Let's say we want to find out a what is sorry, not this one. You want to find out R2. Show ISIS routes IP route. One second. Show ISIS IP v6 route. Okay. Always I used IPv6 for IPv6. Okay. Otherwise it will only use IPv4. Let's say you want to find out something. So SRv6 locator like this. Okay. I copy this, paste it, detail. Detail is there. Sorry, just one second. Yeah, this one. Label none, low priority, source this. See, it's already where it is, infinity 1. Okay, it's not going to show. In BGP you can see it, right? But here we are not able to see this. So basically actually in IPv6 in ISIS we can see this. Just one second, I will show you. In the database mode, show ISIS database. Let's say we say R2 Verbros. If we do this, we will get all the SRv6. Then see F2. So there it is. It's a PSP usage structure. So if I try this now, what will be the size of my this? What size I have used? 48, right? Okay, it doesn't show the information like this, but in database you can see what structure it is. In BGP, the command will be show BGP VRF, if VRF or otherwise VPN before address family, the prefix entry. Then you will see the details of the seed. For example, here we can see this is what index seed. In the database, the information is there, but it's not showing in the show ISIS route command. But if you do a show BGP VRF 1, right? And let's say we say 7.7.7.7 detail. You get the SRv6 functionality here. Okay. So there's a little bit of difference. In BGP, you can find it out differently. In ISIS and OSPF, you will find out in database, not in the direct prefix detail. Based on that, once you know what functionalities, you can find out how to get to that path via Ceph. Ceph will be your main tool to troubleshoot here. Because the forwarding is very ambiguous. It's going to forward based on the destination SRv6 seed. That's it. So based on the Ceph table, how destination seed is programmed, you have to troubleshoot. Right now, how did I easily find out? It's an easy topology, R1, R2, R3. I just check the Ceph table. In the Ceph table, I find out that this seed is programmed to this hop program is to this hop. Right, for example, simply I'm again doing this so that you have this information again. So if I copy this seed value, show Ceph IPv6. I get the entry. Next hop entry, right? For this, let's say customer is expecting some other path, then you can understand there is a config issue, programming issue, something has happened. This is the same thing. It's exampled, it's the same thing. What I am saying so far, right? It's just how it's actually theory-wise work. How the microseed, what it is saying, we remember that microseed operation we did, insert and all these things. It is what it is saying. It is a plain IP forwarding packet, best effort slice. So if here you see this, what it happened, shift 16-bit, it becomes 7. So on 8, the packet came, carefully check this. On 8, the packet came like this, 800, 700. On 7, what it happened when it reached, it removed this 800 field. 16-bit shift, I told you, right? Shift and insert. Then what happened? On 7, when it came, this packet will be, what will happen after it goes to 7? Anybody? 7 will be removed. See, it's removed. It's saying go to 2. Correct. And if it goes to 2, what it will do? Because the endpoint instruction is there, it will do that functionality. Let's say it's the L3 VPN NDT4. What is the rule? I will remove the complete encapsulation of SRv6, do a manual IPv4. Why IPv4? NDT4. If it's a NDT6, I will do a IPv6 lookup. Basic IPv6 route lookup. There are different tables in XR. IPv4 has a different table. Even in XC, IPv6 has a different table. So by that function, I can understand what I have to do. Okay. That's what this is being mentioned here. Okay. So this was the lab. You can go directly in this link. You can search this particular lab. This lab is fully available. You can configure it. That there is a guide also to help you out how to configure, and you can do your testing. I'm just showing that same lab today right now. Okay. Everybody has full access to it. Log in with your Cisco account. You can take as much time as to practice on this lab. Okay. You can configure base by base how to do this. on the lab. Okay, there's a guide to it, step by step, it's there. But I'm going to show you a basic simple configuration. As I said, for all the routers, this will be done. This highlighted part is based on the router. For R1, this is 1. For R2, it will be 2. R3, it will be 3. So as SRv4, now always remember SRMPLS, try to take as a reference. As in a SRMPLS, there is a global box, global block. In SRv6, there will be a global locator. We will configure. Okay, local locator you don't have to configure. You see in the slide we have talked about the concept GB, LB. GB is your global block, LB is your local block. So you are configuring this local block. Remember this, why? This is a scale. There is a limitation, you cannot use infinite number of this. When you will go into hardware training for Rakuten, you will come into this thing. Customer just cannot use infinite SRv6 locators. Okay. This functionality, right, in the SEP table you are inserting this, that takes hardware resource, right? Software you might say I can insert 1 billion SRv6. Where is the ASIC place to insert 1 billion? Right? So there is a limitation in hardware. So you have to remember this global block. It's very important. Second thing, SRv6 locator. What is this? See this information. SID structure and SID. As I told in ISIS database, OSPF database, you will get the details of your SID. In BGP, what is the command? Show BGP, VRF or VPNV for AFI, basically VRF or default if it's default, AFI, then you put the prefix information, you will get that SID if inserted there, or any kind of SID there, you will get that information, correct? So this is all the there for the SRv6 part. Anybody has any question, guys? I know many of you are sleeping, many of you have almost tired out, but please remember this. You are going to get SRv6 cases very soon from Rakuten. Okay. Rakuten is coming and attack is already there, I believe. But you are getting shielded from it. They are getting shielded right now. They are new guys. So they are going to not get these cases. They are going to deploy SRv6. Many Australian customers are deploying SRv6. Don't go there and just get seated there then. That customer shows you my SRv6 is not working. You don't know what to do. Madhul has one SRv6 case. He just told me, I don't know what to do here. What is this? Right? This is what SRv6 is. It's a complete new paradigm. If you understand so far, whatever we have learned so much, right? It's a little different. Not little, it's completely different. But the concept is similar to MPLS. How we work in MPLS, right? It's very similar to that. Okay? Okay. I think I will end the session now. Thank you, guys.
Thank you.
Thanks. Thanks, everybody.